So, like, it means that will there be any change of amplitude?
Yes, there will be.
There will be change of the amplitude.
Oh, from
Yeah, you're right. You can make the curves and see yourself. You can
yeah.
make the waves and see yourself.
Oh, which one should I do? Sorry, I think it cut off a little bit, but should I do the derivative of sine 2x?
Okay, first write sine of t.
Mm.
Okay, now take the derivative of this sine of t. It would be
Okay.
cos of t. Now you can hide all the other waves if you want to just get a want to get a feel of the other curves, like the two curves you have just drawn.
Mm-hmm.
Now look at them. Is there any change in the amplitude?
No, it's the same.
Yeah, they're same. So
Mm.
why they are the same?
Um, I think because they are taken from. Mm,
Yeah, think about it. Think aloud.
uh,
Like whatever you are thinking, just say. Feel free to
okay.
say.
Um,
Yeah.
let me see. Um, because they have the same domain, like they're both divided by, when you do sine and cosine, you take, they're both divided by the hypotenuse. Is that right? Or
Oh, I guess so. We haven't divided anything but the cos of 2t as well. Like we were not dividing it with anything.
mhm. Mm,
Okay. Now, 1 minute. Move the algebra window up. Now, look at here. When the function which was g of t, it was cos of 2t. And
mhm.
when you took the derivative of it, what it became?
This one, the cos of 2t, it became 2 sin x, 2 sin 2t. So they're similar
Yeah.
because when you take the derivative, it equals the other one. Anyway,
Hmm. So what is actually the addition in the derivative there?
the 2, right? That is the only thing
Yeah,
that added.
that two, like that two, which was not in the actual function, but when you took the derivative of it, it came out in the derivative, right? Am
Mm-hmm.
I right?
Yeah.
Okay. So therefore, when you took the derivative of it, what was the amplitude of it?
It increased to 2.
Yeah,
Right.
it increased to two. So if we are gonna take one more derivative of this term, 2 sine of 2t, what it would be?
Sine 2t, right? Or sorry, not sine, cosine 2t, because the 2
Okay,
was,
you can write it in the algebra window. Sanya, what is your major?
I'm thinking of either doing a chemical engineering major or a math major, but I'm not.
Okay, you are right now you are not enrolled in any of the program.
No, I'm enrolled in well, for me at least, you just take classes. So I'm enrolled in a lot of like chemistry and like biology and math के courses, but it's not like
like you are not doing in like in which grade are you then?
well, I'm going into college, लेकिन मैं community college में जा रही हूँ पहले year के लिए और फिर मैं transfer कर लूँगी. So community college में they just have like they have you can major in certain things or you can just do general studies. तो अगर आप general studies कर लेंगे तो फिर you can take any classes.
Okay.
Mhm.
So you are studying biology, maths, physics, all of the courses.
Not all of that, but chemistry. I'm taking psychology and calculus में भी ले रही हूँ. So
Okay. So this cos 2t, you have taken the double derivative of, you have taken the derivative of 2 sine of 2t.
Yes.
Okay, there is a command in GeoGebra, like you can just write the prime, like to write h prime of t. Then it will the GeoGebra will take the derivative for you. H
Okay.
prime. Yes. Now write t, like brackets, small brackets t. Yeah. Now enter it.
Oh,
Yes. So the
boy.
GeoGebra has taken a derivative for you. Okay.
Mhm.
So well, one thing. Okay. So when you first taken the derivative of sine of 2t, it was
Um, 2 sine 2t.
yeah, and then when you have taken the derivative of it the second time, so what is the answer now?
4 cosine 2t.
Yes, now it is for cosine of 2t. So uh, now look at the waves of the 4 cosine of 2t in the GeoGebra window.
Mhm.
So what is the amplitude of this wave?
It's gone up to 4.
Yeah. Why it's going to 4?
Because the front it is 4, so it's 4 cosine 2t.
Yeah. Because we have just multiplied cos of 2t with the 4.
Mhm.
Okay, so now the amplitude is of the wave is 4.
Mhm.
And when you have just simple like sine of t or cos of t, you do not have anything multiplying with the t.
Mhm.
So it doesn't matter how many derivatives you are gonna take, the amplitude of the wave will remain the same. Uh, Halima, you have got it what I have said?
Yes, yes.
Yeah. But when you have something multiplying with the angle, so it means that your derivatives are gonna change. Your amplitude of the wave is gonna change. Okay?
Mhm.
So now if we are like changing the like we are just we just took the derivative in algebra and like we on the one side we are looking on the waves like they are changing and the amplitude is changing, but on the third window we have circle. So when we are changing like when we are changing the waves we are changing sine of t to sine of 2t, and when we are changing sine of 2t to 4 sine 4 cos of 2t, so what would be the change in the circle?
Mhm.
Can you think of it about a bit like what would be the change in the circle there?
I think the circle would get bigger because the amplitude and although the periods are staying the same, amplitude is rising, or it's getting bigger.
Yeah, you are right. Okay, so okay, one more thing here is that K. when we are like taking the derivative of sine of t and sine of 2t or cos of 2t. Okay, we have just like a function, and we have taken the derivative of that function. So do you know about velocity? What is this?
Yes.
Yeah. So velocity is the derivative of function with respect to,
The changing time or changing.
yeah, the change in time, like with respect to time. The change in function
Time.
with respect to time. Like how your function is changing with respect to time, so that is your velocity. And then you
Mhm.
are gonna take the derivative of velocity, what it would be?
Um, what's the derivative?
The derivative of velocity.
What acceleration as well?
Okay, Sanya, do you drive?
Yeah. I know how to.
Okay, so it means that you drive, like. So,
Mhm.
have you ever noticed, like, sometimes when you accelerate,
Oh.
when you have to turn your car, and when you are like trying to change the speed of your car, so your car accelerates, right?
Yeah.
So it is in the same manner, like we just call like, so the speed is velocity, as we all know.
Hmm.
Am I right?
Yeah.
So when you try to change the velocity of your car, like the speed of your car with which it is like with which it is going, so your car starts to accelerate, right?
Hmm. Yes.
Either you are increasing the speed of your car, either you are decreasing the speed or velocity of your car starts to accelerate.
Right. So
Okay.
the derivative
Yes.
of velocity is acceleration.
Yeah. And so, what is acceleration in the language of maths? Do you know maths is a language?
Yes.
Yeah, maths is a language, and in the language of maths, we just call this acceleration the time derivative of velocity. Like the velocity is changing with respect to time, so the result is acceleration, right?
Mhm. Yes.
Okay, so now when you are like when you are moving in a circle, when you are moving in a circle, so your car is showing the speed, and that speed is constant. Like your speedometer is showing the speed, and that speed is constant.
Com-
But you will find yourself continuously accelerating your car because you are just trying to turn,
right.
isn't it?
Yes.
Isn't it beautiful?
Yes.
Okay, so you are not changing velocity, but still there is acceleration,
Mhm.
and we call that the acceleration is only when we are turning, when we are like when we are changing the speed or the velocity of our car. Okay. Um. So, Sanya, there is a circle, and there is this point C that is moving in the circle.
Right.
So, we are just gonna keep the velocity. Okay, so we are just gonna find the velocity of we are
No,
just trying to
no,
find the
one minute,
velocity of
one
this.
one minute, 1 minute,
Okay,
Sidra.
okay, sir. Okay,
I,
okay.
I got a message from Wasim that they do not have the Skype link.
Sir, I have sent them.
Send them again.
Okay, I'm sending them again.
And always send a copy to me. We
Yes,
just
sir.
said we don't have any link of Skype.
Okay, sir, I'm sending them again.
Yeah. And if then please repeat something so that they come up to what you see. Sania is much more intelligent than them. She can pick up very fast, but you should try to make them comfortable also. All right?
Okay, sir. Sir, I have sent the mail. Can you please check, Halima? Have you received? Sir, I have included you as well.
Oh, yes, I got it. Yes.
Okay. So, okay, Sanya. So, if you are moving in a circle with a constant speed, so will there be any acceleration?
Yes, there will be.
Yes, there will be acceleration. Okay. So, why there will be any acceleration when the speed is when the speed is constant?
The distance you're constantly changing the direction which you're going in. So
Yeah, very good. Yeah, as the direction will be changing, so there is the acceleration because of the direction. And you know what? There is a beauty about vectors. Like in vectors, in vector algebra, basically, like there is a fancy name. We call it vector algebra. Okay, so in the vectors, so direction is as much important as much the magnitude.
right.
So we always have to take care of the direction, and when there is direction, so it means that you have just a new set of exams and the rules, and you have to go through them. So the vector has its own algebra. Vectors have vector have their own, like you can say that vectors have their own attitude. They have their own algebra, and they do not like typical scalars, which are easy to understand, easy to handle. So the vectors are actually much more complicated. When we are adding them, when we are subtracting them, we have to take care of the direction as well. So, but the very like the most important thing about GeoGebra or the software is that it doesn't care about vectors. Like you have to just typically type as you write, like as you write down in your calculator 2 minus 2, that would be equal 4. And in GeoGebra, when you write actually about the vectors, like two vectors, and you want to just add them, you are just gonna write with you, and the GeoGebra is gonna do the work for you. You don't have to plot those vectors and then look at their direction, and then you have to again look at what would be the resultant and the resultant magnitude and all of those fancy calculations. So this is why GeoGebra is like a marvelous platform to experiment maths.
Mhm.
Okay, so can you please zoom into that circle which you just made in the yes, this one, perfect. Yeah, it's fine. Yeah, you can zoom in. Okay, now stop it. Stop.
Oh, sorry.
Okay, now do you know in the increment section we write 0.2, we wrote 0.2, okay? So what does 0.2 means?
That it's like going by 0.2, I guess. Like that is the.
Sir Ashraf, you are trying to say something?
No, I'm not trying to see something. There was some window which has opened up, and I was trying to close. You go on.
Okay. So Sanya, the increment which we wrote 0.2. Sorry, I just missed your answer. 0.2. So what does it mean?
It means that we're traveling by like 0.2 on a scale of 0.2, I guess. Like, I don't know if that makes any sense, but would you say like,
Okay.
if we put increments to maybe 1, then it would go from maybe like -1 to 0, then from 0 to 1.
Yeah. Okay. So when there is when you are moving in this circle, so like you can see that there is a gap between each dot.
Right.
So there is this distance between each dot is
0.2 or the increment.
yeah 0.2. So this distance is 0.2 because our increment was
0.2.
Because our increment was 0.2 in the slider.
Right.
I hope so I'm not confusing you. Are you comfortable?
Yes. No, it makes sense.
Okay. Now make two vectors.
Okay.
And in the first quadrant, and those vectors must start from 0, and their and a little bit more. Yes.
Okay. Should I make 2? Can it just be any 2 points, or should I do it?
No,
okay.
Together with each other, like like this.
Got
Now make one more with it. Okay, so now you can take that. Now you can take that move, the cursor. Okay, so this is like we have taken the vectors, and now we are gonna take the. We are gonna find the velocity of these vectors. So how we are gonna find the velocity? Okay, now this is another way to take the derivative or to find the velocity. Okay, so now you are gonna write okay, Sanya. Now you have got okay. Now take the difference of two vectors. Like there is v, u, and w. So you can take the difference of u minus v.
Please zoom it, please. Zoom the third window.
Okay, sir.
And shift it down. Yeah, that's right.
Okay, so
yes,
it got.
Okay. So it is w minus u.
Yes.
Okay. You Sani, you can just shift the order, like make it u minus w.
Oh, achha.
Yeah, just make it u minus w. Okay, so now you have taken the difference of these vectors. To find velocity, you have to divide it with the time as well. So our time is in between these 2 points. What was our time?
From 0.2.
Yes, 0. So you are gonna divide this u minus w with 0.2. No, first make the bracket. Yeah, now divide it with 0.2.
I'm wrong. 1/8 second.
Okay, it's fine, no problem.
Sania, did any teacher in your class did something like this?
No.
So
मेरे
that
teachers इतने interactive नहीं थे.
so that will be new to him. That means Sidra, please slow down. You're going too fast.
Yes, she's going right speed. Don't worry.
Huh? If he goes too fast, please
Yeah,
slow down.
I'll tell her if she's going to.
बता देना, शर्माना नहीं.
नहीं
हाँ?
नहीं नहीं कहूंगी. मैं उसको बता दूंगी. मैं उसको बता
सानिया
दूंगी.
शर्माना नहीं है बिल्कुल भी.
Won't. अच्छा.
Okay, Sania. So what you have just found right now?
The vector for the vector the difference of the vectors u minus w over the time. So I found the velocity of the vectors. Okay.
Yes, you have found the velocity of the vectors, and so you can just change the position of A to G.
Change. Okay. All right.
To G. And the
Uh,
last to G.
G. Oh, sorry.
Yes, it's fine. Okay, so now look at it. So you have just found the velocity, which was velocity vector like A. Can you find the length of this velocity vector?
Yeah.
Come down in the algebra window and do write length and
Is
A. So what is the length?
0.9.
0.94. Okay, so it is approximately equals to 1. So is our length is right?
Yes.
Are you really sure about it?
Yes, I'm sure. Or actually, well, okay, yes, I'm sure.
Okay, so you are sure about it. Why you are sure about it?
Because we found we only found the velocity of like the between the two vectors u and w, and then I don't know actually.
Okay. You are sure about it, but you don't know that. Okay, so
because I don't know why we wouldn't be right, like because we did everything right. We found the velocity of the two vectors. So
and then we divided it with by 0.2.
by the time.
Okay, Sania. When we look at our point which we just made and by which a circle was being plotted on the second graph, look at that point in the algebra window.
Oh,
the point by which we traced the circle.
see?
Yes, this point. What does this point is saying?
It's the cosine m and sine m.
sine of m. By the help of this point, we trace the circle on our second graphics, right?
Right. Yes.
So, and when we trace the circle and we found and we made the position vectors, and then after making the position vectors, we found the velocity. And when we found the velocity, the magnitude of that velocity is?
It was 0.94.
Yeah, which is approximately equals to
1.
And look at this point, which is saying cos of m and sine of m.
Hello.
So why this magnitude is 1? Sanya, there's a connection between cos of m, sine of m, and the derivative of them, and the derivative of those position vectors and velocity, and that came out to be 1.
Should it have?
Think about it and think aloud. Like, you know, when you are in chemistry lab, you have so many of the chemicals in front of you, and you think that these chemicals are very expensive, and if I have performed an experiment, I would waste chemicals, and so there is like the chemicals are expensive, so there is this thing in your mind, so you think a lot of the time before doing an experiment. So in maths, we actually we have no fear of losing any kind of material, because we have plenty of them. We are just gonna write in the algebra window, and we are gonna see and look into the graphics. So there is so much space for making those experiments in your head. And so when in maths, we just do the experimentation like this. We think about them aloud, and this is the experimentation in maths. And there is no fear of losing any kind of material, any kind of chemical, anything. So make this experimentation like more fun and think aloud. Whatever you are thinking, just say it. You know, when sir teach me, so I just keep saying, and I don't know either I'm saying right or wrong, and mostly I'm telling the wrong answers. But it's all the fun. It is all the way we go through this.
Okay, I think the connection is because all these points are on the circle, so they're all like related. Not really well. All and the vectors that are being made. Wouldn't you say that they're like the radius of like the circle, because they're taken from the origin and gone to a point on the circle?
Yeah.
So that'd be the radiuses. So then the velocity, or the length of the velocity, I guess it would be more than the radiuses, or larger than the radiuses, or
the radius was 1, and the magnitude of velocity is also 1.
Well, then they're the same. So they're
Okay, so there was this cos of m. If you are going to take the derivative of cos of m, what it would be?
Cos of it would be sine of m.
Yeah. So is there any kind of addition? Is there any kind of number multiplying with sine of m?
No.
So it means what is the number here?
Oh, it's 1. It would be 1. Just like you just multiply 1.
Yeah, it would be 1. So when you took the derivative of cos, it came out to be 1 sine of m.
Mm-hmm.
And when you just took the derivative of the vectors and you found the velocity vector, and the magnitude of that velocity vector is also
1.
1.
Mm-hmm. So that is the correlation then? Because
yes, this is the actual relation. Okay, you are going to appreciate this relation more when we will be progressing forward. So now you can find the another velocity vector of v and u.
V and U, okay. And U. So it is C, and then is 1.5.
Yeah. Okay, now look at it. When you took the derivative of the other two vectors, it has also come out to be
Around 1.
yes, around 1. So because you are finding the velocity and you know that you have constant speed, so therefore all the velocity vectors are coming out of
I'm sorry. All the velocity vectors will come out from the same thing as the speed, I guess.
the same.
The same. They'll come from the change in speed over, or the change in direction over the change in speed.
Yeah, so they all are coming like they all gonna have the same
Values, or not the same value, but same length, right?
yeah, they're all gonna have the same magnitude. Okay, so okay, Halima, can you set the position to E rather than F?
Oh, okay, yes. And
Okay, now now you can you can find the acceleration from these two vectors, from these two velocity vectors.
that's it. So I will do. And also changed. So.
Sania, I am not able. 1 minute. Let me rejoin again because I guess so. The screen is stuck at my side.
Oh, you know.
Okay. Have you found the acceleration?
I think so. Yes, I did the rate of change.
Okay. C minus A divided by 0.2. We
Mhm.
have to divide it with time as well.
Okay, right.
Okay. So
Got 1.34.
okay, so the length is coming out to be 1.34, and what you are supposed to do is that actually our vectors, velocity vectors, were not exactly of one magnitude. Therefore, our acceleration vector is coming out to be 1.34. So if we are just gonna just slightly move any point E or F to make them equal to, so that their magnitudes will become equal to 1.
Okay. Oh, I think it just got more.
Actually, the number 0.2, which we are dividing it
Oh,
with, is a very small number. So, like the system becomes very sensitive. No, it's fine. You are not supposed to change it. 0.2 is 0.2 is the same. I was the correct. I was actually telling you that the 0.2 is a very small number. So the system becomes very sensitive when it comes to vectors. Yeah. So,
move
so now your length of A, the vector A has become 0.9 now. So like you need to do that. Open the trace of A. Open the trace of A and move it. The trace of not this, the point, the slider M by which we were tracing the circle. Yes, that was point. Move it. No, zoom it, zoom it more. Yeah, now arrange your points. Okay. Let the circle. 1 minute. Let A trace it first.
Okay.
Let the point trace the circle first. Yeah. Okay, now you can stop. Now you can stop it and don't move the graphics. Okay.
Don't move
So
the. Oh, shall I move the
yes,
G?
now you can. Now you can like actually drag your points to the exact points.
Okay. Should I do it with E?
Yeah, very good. Yeah. Okay, now you can check the lengths. Are they one now?
Yes.
0.
Oh, okay. Well,
Yes.
B is very close. A is very close to being one. So let me just.
Yes. So it is fine now. Like you have got the length of C vector 1,
I
A
have both.
vector 1, and acceleration is 1 almost. Okay.
Mhm.
So now you can like think about it, like the vectors are very sensitive.
Mhm.
If they are like slightly out of the number like where we want them, the result would be catastrophic.
Yes.
Okay. So now you have found the velocity vector and the acceleration vector of your circle, the
Mhm.
circle which has the frequency 1. Okay?
Right.
Because it was cos of m and sine of m.
Mhm.
Now just change your point. Now just move to the point from which we were tracing the circle.
C.
The point cos of m sine of m. Yes, yes, this point. Now change the frequency from m to 2m. No, you are just gonna click yes, and now change it from m to 2m. Yes, very good. Okay, so now you have changed the frequency from m to 2m. So move to the second graphics. You can actually change the position of the acceleration vector we just found. Uh, take it to the E. The acceleration vector.
Oh, this one.
Yes, yes, this one.
Okay.
Move its
Take it.
position to E.
Should I do E or F?
Yeah, it's fine. You can do anything, E or F, whatever you like.
Oh.
Okay, can you change the color of all these 3, 4, 5, 6 vectors and make them brown?
Mhm. Okay.
Okay, so okay, Halima, if you are gonna just if you are like gonna do the same process with whole circle, you will come out to be with the same kind of position vectors, same kind of velocity vectors who have magnitude 1, same kind of acceleration vectors who also have magnitude 1, right?
Mhm. Yes.
Okay. Why? Because we have cos of m and sine of m. The frequency was 1 there. Cos of 1m, sine of 1m. Now you have changed the frequency from 1 to 2. Now you have cos of 2m and sine of
2m.
2m. Yes. So now you can make a circle with this frequency. If you are gonna just move the slider, play the slider. So first zoom out. Setting graphics. Okay. Yes. Okay. Before moving forward, we can do one more thing. Like before moving forward, just want you to do one more thing. We here right till now we have found the velocity vector and acceleration vector of magnitude 1. So can you make the waves here on the first graph of cos of m, and then you can take the derivative of them. You can hide all the other waves. I guess so. We first found it like, okay, cos of okay, you can here we have the first derivative and the second derivative also of cos of t. Okay, hide the sign, and only show the cos. Okay, so take the derivative of cos of t and sine of t. What you will get?
You get 2 sine 2t.
No, I am asking you to take the derivative of only cos of t. What it will
Oh,
be?
only positive. Oh, then you would just get sine of t.
Yes, sine t. Now, so what would be the amplitude here of the derivative?
1.
Yeah. So when you took the first derivative of cos of t, it was sine of t, and the amplitude was 1. Therefore, when we took the derivative of position vector, we found the velocity, and the magnitude was
1.
Yeah. So if I am gonna take the derivative of sine of t one more time, it come out to be
It come out to be 1 again. Or
if you are gonna take the derivative of sine of t.
sine of t, then it would just be cosine t. So, yes, it would be 1 again.
And yeah, and the amplitude would be
1 as well.
yes. So when you are gonna take the derivative of velocity, you found amplitude, and acceleration, and the amplitude of that acceleration was
1.
1. Okay. So like this so now you have changed your sine of m and cos of m to cos of 2m and sine of 2m, right?
Yes.
And yes, you have changed the frequency from 1 to 2. So now you have traced out a circle there. Okay, you are supposed to trace the circle only once. Like you have traced it 2 times, so that's why we have these points which are very close to each other.
Let me redo it.
You can just move the second graphics a bit, so these dots will vanish, and you can just plot it again only for once. I think so you are doing it, but my end it's not showing.
Okay.
So
I've
so
tried.
now in the second so now in the second graphics, you can look at now when you have changed the frequency from 1 to 2, the distance between the dots has been
Increased. It's increased.
yes, the distance between the dots has been increased when you increase the frequency.
Yeah.
So there is no change in the radius of the circle. There is no change in the like amplitude or the radius of the circle. But what have changed by increasing the frequency is the distance between the two dots, which are like dotting circle. Okay, so now you can in the second quadrant. Now you can place the vectors, C vectors, as we did in the first quadrant. Okay, so now you can find the velocity of these vectors and you can find the acceleration of it, and then just find out what are the magnitudes of those velocities and acceleration. But what do you think? What would be the magnitudes?
I think they're gonna be 2 because now if you were to take the derivative of because we changed the graph or the circle to cosine cos 2 of 2m. So if you were to take the derivative of both of that, it would be 2 sine m. 2 sine 2m. And then the same thing with the sine. So the amplitude would be bigger. Same with the magnitude would be more. So I think they all would be just 2 now instead of 1.
This is exceptional, Halima. You have actually got it, and this is seriously amazing. Okay, so you can just wait and clap for yourself.
Yay.
Because there's a moment to cherish, to celebrate, isn't it?
Thank you. Actually, it's very simple if you like. I mean, the way that you explained it was very easy to understand. So
something special happened.
Huh?
Yes, sir. Halima has decoded the algorithm. She has decoded the algorithm.
She has decoded the algorithm. She should get given a Nobel Prize.
Yes, sir.
You are exceptionally intelligent. Do you know that?
Thank you.
I'm not praising you just because you are daughter of Ijlal Shah. I can read faces, and now it is more than reading faces. I have interacted you in several workshops, and also you keep a very low profile, but you are exceptionally intelligent.
Thank you.
But there is a but also.
Okay.
Those people who are exceptionally intelligent, they have a lot of responsibility on their shoulders so that they can use their exceptional intelligence to positive use. You see, an intelligent mind is a difficult mind.
Yes.
It is very difficult for an intelligent mind to keep it concentrated on one. So it is now your responsibility that you should use your intelligence for a good purpose. Huh?
I will. I will. Okay,
Sanya, now you can find the velocity and velocities in the same way we did before. Like,
Sania, is this lecture much more illuminating and less confusing than the last one?
Yes. Or no, I think the The last one was good. I think that since we just had a little like bump in the road, it's what just say this one is easier to understand. Okay.
But this was something where you have that aha moment, huh?
Yes.
Huh?
Yeah.
But
Yes.
you didn't. You are so low profile. I didn't hear the aha moment from Sania, huh?
Yes. Yeah. I
Why,
mean,
why don't you express yourself? Why don't you jump? Huh?
I
You
don't know, sir. मैं
you,
कर
al
लूँगी.
you always keep a low profile.
Not
In
always, like sometimes.
uh,
नहीं.
in in friends also you do not laugh too much, and
नहीं.
no.
नहीं, मैं बहुत हँसती हूँ. हर चीज़ के ऊपर मैं हँसती हूँ. जब मैं दोस्तों के साथ हूँ.
तो फिर हम दोस्त नहीं, हम दुश्मन हैं.
नहीं. नहीं, sir. नहीं. But I do. I remember smiling जब मैं when Sidra said that I got it right. तो खुश तो थी.
क्या होती है?
I was happy. मैं बस इतनी vocal नहीं होती हूँ. I'm not that.
How,
ऐसे.
how can we open you up?
No.
That's our challenge. How can you behave uh, as if Sidra and myself? Well, okay, leave me alone. Uh, is dirty old man. But Sidra is not very older than you. She can become a good friend of yours.
Yes.
Huh?
Hmm.
You can jump with her.
Yes.
Huh?
Yes.
Well done, Sania. Well done. Really, I'm not surprised, but I am really happy that you have
Thank.
discovered something yourself which you might have studied, but
Hmm.
you have the teacher might have taught you, but they might have taught you in such a manner that you could not make a head or tail of it, huh?
Hmm.
And now perhaps you understand it much well, huh?
Yes. Thank you.
So thank you very. Don't say thank you to me. After this, never say thank you to me. All right?
Okay. Okay. I will.
Do you say thank you to your father also?
Yes.
Oh, and he accepts that thank you.
Yeah.
मैंने इजलाल के कान खींचने अब.
अच्छा तो मैं बैठी हूँ. We would divide it by 2, right? Because now the distance between the points is bigger. Or is the actually the distance is still the same?
We are gonna divide it with time, and our time was time period, and our time was
0.2 or
yeah, it was 0.2. So yes, now you can find and the similar. Okay, you are just setting the position. Okay, okay. Sanya, the back. Okay. Okay, Sunny, have you found both of the vectors?
Yeah, but this one is very long. This one goes until I don't think I did it right.
Can you please zoom there? I think so. The vectors here are L, K, and J, right?
Oh, it's L. Acha, acha. I put I. There. Acha. Thank you.
Thank you
Okay.
again. No thank yous in this workshop.
Okay, I won't say.
You have to become
Okay.
Tanya here now.
Hmm. Oh, the lengths are the same. They're almost two.
Yes. So lengths are the same, and they're almost two, as predicted by you, that the lengths would be two. So now, if you're going to take the one more derivative, and if you're going to find the acceleration, so what would be the length of acceleration?
If you take one more derivative of it, then it would be the length of acceleration would be 4 because okay.
The
Yay.
length of acceleration will be 4, because when you are going to take one more derivative of 2 cos of 2m, so it would become 4 sine of 2m. So therefore, the length of the acceleration would be
4.
Yeah, very good. So now you can find the acceleration vector, and you can check that if your predictions are right or wrong.
Yeah.
Okay, because when you have GeoGebra, so you can like perform your experiments. You can just you just can't think about that. Okay, so that would be the answer. And when you perform the experiment, so you can see the results yourself as well.
Mm-hmm.
Before GeoGebra, it was very hard. I sometimes think that, okay, if there won't be any kind of GeoGebra, so how do like people used to do maths? It was like to perform experiments, to do on the graphs and everything. But now it's very easy. You have to just type, and you will be getting the results.
Uh, 3 points. Should I change? Should I move the points so that it's exactly 2 or?
Okay, so the length is 3.45. So as I told you that these are like the vectors are very sensitive. So you can actually like trace out the circles and check that if the points are exactly on the same points.
I think they are because like it went over to the
Okay. So first, no, actually, no, the points were fine. First zoom it. Zoom it first. Zoom it so that it will become like right on the second quadrant only. Zoom it on the second quadrant only. Yes. Uh, the way that all yes. Now you can trace. Now you can trace the circle. Just once. Okay. Just stop it. Yeah. Now you can exactly like place the points. first place all the 3 points, then you can look at them. Okay, so now your lengths are almost 2, 2, and 4. The velocity vectors are of 2, and okay, don't make them bigger than 2. The less
Okay.
is fine. Like if it is less than 2, it's fine, but don't make them bigger than 2. I think so it's fine. Like a little bit. This is fine. This much change.
Okay, sorry. Oh. I just say. Oh, I made one bigger than 2 eggs. Okay.
Okay. So yeah, this is perfectly fine. Okay. Now zoom off.
Mm-hmm.
You can place this acceleration vector on on like change the position of this acceleration vector to the acceleration vector.
Oh, okay. You will.
Yes,
Oh,
change
which
its
one?
position to H, I, or D, whatever you would like, whatever you like.
All right.
Okay, and now make all of them the color of blue. Make all these 6 vectors blue.
Okay.
Okay, so now when the frequency was 1, we got the velocity and acceleration. We saw that the velocity and the acceleration have the magnitudes 1. So when we have the velocity, the frequency 2, we found that our velocity vector has magnitude 2 and our acceleration has magnitude 4. So now we are going to change the frequency from 2 to 3. So what would be the waveforms on our first graph? Okay, now change here from frequency from 2 to 3.
Here? Or at the point?
The point. Okay, now you can hide this wave in the first column, in the first graph. Okay, now do right here cos of 3m. So actually, okay, now don't write 3m. You can write cos of 3t.
Okay.
Now, okay, it's still a number. It's not a wave coming out. You have to click on the first graphics. Okay, now write cos of 3x. Click on the first graphics and write cos of 3x.
Okay. Now it has come.
Yes, and now take the derivative of cos of 3x.
So there's
Very good. Now take one more derivative of it.
only 9.
Okay, now check the amplitudes of these waves.
Okay, the amplitudes. Oh wow, those are big waves. Of this, the second derivative would be 9, and then the amplitude of the first derivative would be 3, and then the amplitude of just cosine 3x would be 1.
Okay, so now you have actually now if you are gonna trace the circle.
Mhm.
So now look, stop. Okay, actually we want it only one times in the third quadrant. So you can actually move a bit. You can actually move the screen a bit, and you can again like trace the circle. First take it to the 0. Yeah. Now start tracing. Okay, yes. So we have got these 3 dots, and now we are going to repeat our process of making the vectors on this frequency.
Okay.
Okay, you have to make one more. You have to make one more, so that uh, we cannot find acceleration if we do not have 2 velocities. Okay, so here's a quick question. What would be the magnitude of velocity vector and the acceleration vector?
What would be the, wait, sorry, what was it?
What would be the magnitude of the velocity vector and the acceleration vector?
3, or actually, yes, 3, I think.
Yes, very good. And what about the acceleration?
The acceleration would also be 3, I think.
Acceleration will be 3.
Yes, I think so.
Velocity and acceleration would be same, like both would be 3.
Yes.
Okay, so you can find the velocity vectors now.
Okay. Mm.
Hope so you are not tied. Halima, the vectors are V1, U1, and W1.
Oh, I'm doing the points. Okay, thank you.
Are you tied?
Yes. How do I do the sub? Should I just copy it?
Yes.
How do I sub? Because I don't think my computer has that option.
Which option?
To have a sub the subponent, like the one at the bottom part.
Okay. You don't have the minus. Like if you're gonna take the shift and press the minus, then it would be this.
Okay. Oh, I didn't know.
Okay, so now you have got it.
Mhm.
Okay, so if you are tied, like, so we can just stop here.
No, it's okay.
Okay, so
And this is it. I think I did the.
have you clicked on the graphics too?
Yeah.
Okay, now it's fine.
Mhm.
You can check the magnitudes or the lengths of these three factors.
Okay.
Are you going to find the acceleration? now you can find the lengths of these velocity vectors and the acceleration vector.
Okay.
Plus d subscript 1.
Mm-hmm. So they're around 3. It's all around 3, and then the last one is around 9.
Now, check. Yeah, and why there are so. So, Hariba, like why the velocities are 3 and the acceleration is 9?
Okay, so the velocities are 3 because when you differentiate it the first time, it goes up by, well, like the number in front is 3. So that's why all of the velocities and acceleration is 3. But then when you differentiate it a second time, the 3 turns into a 9 because you multiply 3 by 3. So that's why the acceleration is 9 and not 3, because it's being differentiated twice.
Yes, and very good. So now you can just think that there is a relationship or there is a connection between
Mm-hmm.
these waves, time, cause with our circle. So, and one more thing what we get from here is that, like when you are increasing the velocity, so the acceleration is increasing the twice of it. Okay,
Mm-hmm.
so it means that if you are moving in a circle and you are moving in a circle and you try to increase the speed, so the acceleration becomes double. And so what if the accelerations will become so high and the velocity is less? What would be the like side effects of it on you sitting inside the car or the passengers sitting in the bus?
Velocity going high, but the acceleration staying the same. Is that what you said? Um. Hmm. I'm sorry. Can you repeat the question? I think it was.
Okay, my question is that while looking at like whatever we have done right now,
Mhm.
so it means that there is a connection between the equations of the circle, and those equations of the circle are sine and cos. They
Mhm.
have a relationship that is too deep with anyone moving in a circle. Okay,
Mhm.
isn't it?
Yes.
So there is this connection. Okay, so when you are moving in a circle and you have this constant speed, and even if the constant speed you are experiencing acceleration, what if you are still moving in a circle and you try to increase the velocity? So what would be the acceleration?
The acceleration would also increase, but I think it would increase by a lot, because if you try to move faster in the circle, speed up, I guess, in the circle might also get smaller, right? So
Okay. Yes, yes, speak.
um so I think the acceleration would become, I guess,
Okay.
what with the
Okay.
velocity.
Before moving forward to this, I would like one more question. I would like to ask, like when you are driving, so instantly there is a boy in front of your car. So what you are gonna do?
There's you'd move around.
Okay. No, you are not moving around. You are not moving in a circle. You are just going straight. And when you just take a turn into one of the street, you see that there is a boy or a child playing. So what you are gonna do?
You would stop, I guess. Either stop or you would
Yes.
go around the boy. I stopped though.
Yes, you will stop. You are gonna press the accelerator. Okay. So when you will try to stop, when you will try to stop your car instantly, what will happen that you are gonna decrease your speed instantly, and when you are doing this, your acceleration would become maximum, and when you are going to experience a maximum acceleration, would you feel good?
No.
No, you
I
are not going to feel good. Like the acceleration, very high acceleration is not good. It's not good for the person sitting in the car, sitting inside it. So the car is very small, so the acceleration you are gonna feel, the effect of that acceleration would be much less. But now imagine you are in a bus, okay, and then bus takes a turn, and then there is a boy playing. So the driver tries to stop the bus. Now what you are gonna feel? Now the driver stops the bus instantly, and the velocity decrease very sharply. Therefore, the acceleration increases very fast. Okay, so when you experience that very high acceleration, you feel good?
No.
No, you are not gonna feel good. The bad experience will become more bad when you are experiencing it in bus, and it will become more bad if you are going to experience it in a very high speed train. So the amount of acceleration are not good for anyone sitting inside car, sitting inside train, and sitting inside a bus. So from here, what we comes to know that, like, if you are moving in a circle, by whatever the exercise we did today, we come to know that if we are moving in a circle and we increase the frequency and repetition, so when we increase the frequency, we actually increasing the velocity. And when we are increasing the velocity, the acceleration is increasing by the double amount, isn't it?
Yes.
So, so, so would you like to sit in a bus who is moving in a circle with very high speed?
No, probably not.
No. Why not? Like, why?
Because
Who is the culprit behind?
I think the culprit would probably be the acceleration, because you're going at very high speeds in a constant circle, or just in general, it's not a good feeling, because then if you have to suddenly stop, then the acceleration just immediately goes up, like very suddenly. So it creates sort of a like jerk effect, I guess. So it's not a nice feeling. It
Yeah,
probably
so
hurts.
it's not a nice feeling. and we just and we have just manipulated this very thing by our simulations and by our waves, by the sine and the cosine waves, and by the vector manipulation of it. So there is a deep connection of all these things. There is a deep connection of nature with mathematics and how we represent the mathematics. So the mathematics is all about patterns, the geometry of nature, which we actually manipulate and do.
Yeah.
So I hope so you like the patterns we found today.
Good. Yes, it was very interesting.
Okay, thank you so much.
Thank
And
you.
so
Me.
we hope so you have enjoyed today's episode.
Did, yes.
Thank you very much, Sidra, and hope that you, I'm asking from Halima,
Hmm.
have enjoyed the lecture.
Yes, I did.
So you didn't feel the need of me, right? You didn't miss me.
No.
Oh, huh?
No.
So that means, Sidra, you have replaced me quite nicely.
No, no, sir. Actually, I can't replace you. I can never.
Said it. He said it openly.
Yes,
He
sir.
said it openly that Sidra has replaced you, and now we are not missing you at all.
Sir, uh, no, sir. Like, uh, I was not able to conduct this workshop if it were not you behind my back.
Hmm.
I was not behind your back. I was trying to get some sleep after taking some tranquilizer, and I'm so happy to see a smile on Sania. And Sania, do not forget not to say thank you.
Okay.
Okay. So, Sidra, thank you very much. We'll see you tomorrow. Tomorrow there is no class, right?
Nay,
Yes,
Thursday, I
sir.
think. Or
Uh,
at least yeah.
Friday को class है अब, हाँ?
Friday or Thursday.
Thursday को भी class है. But
Or we
no,
can just do Friday, say Friday.
there is a class on.
I
Yeah. What are the days? Class days for the North American students, huh? It is Tuesday and Thursday and Friday.
sir,
Tuesday, Thursday,
sir, I
Friday.
guess it was Monday. It was Monday, Thursday, and Friday.
No, 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 no. It is Tuesday, Thursday, and Friday.
Okay.
Right?
Okay. So, Sania, would you be available now on Thursday and Friday?
Yes, yes.
Okay.
Okay.
Right. So thank you very much.
Yeah.
Thanks to Sidra, who
Thank
has
you.
completely replaced me.
No, sir, don't say this.
And thank you to Sania, who told me the truth. And thank you for not saying thank you.
Okay.
Okay, Khuda Hafiz. Say my salam to
Yeah,
Hilal.
Okay, I will. That's it.
Okay, Khuda Hafiz.